Okay, now in plane part 2 we are going to see some examples on plane. See one example here. We are supposed to find the equation of plane which contains the line and which is perpendicular to another plane whose equation is given by. Now please see, the plane contains the line means the entire line lies in the plane. So the point 1, 2, 3 on the line also lies in the plane. Secondly, the vector 1, 3, 2, which is a vector along the line, is also parallel to the plane. If two planes are perpendicular, then normal of one plane will be parallel to another. I hope you understand this. Let me try to illustrate. You can see that this and this plane, they are perpendicular. So if I draw a normal to this plane, normal to this plane will be parallel to the plane. This. So if two planes are perpendicular, then obviously normal of one plane will be parallel to another plane. So now we have got three coplanar vectors. What are these three coplanar vectors? The first vector is 2i plus 7j plus 5k. Second is I plus 3j plus 2k. And the third vector will be in form of a point. So let us see the situation here. I have a plane. There is a point A, since the line lies in the plane. A point A 1, 2, 3 is in the plane. Any general point R, X, Y, Z also lies in the plane. In addition to that, one vector, say B bar, which is I plus 3j plus 2k, is parallel to plane, or you can say lies in the plane. And another vector 2, 7, 5 also lies on the plane. So the box product of AR, B bar and N bar will be 0 because they are coplanar. So this is the simplest way of getting the equation of the required plane without any much. You can very clearly understand this. The box product B bar, N bar, so we have 1, 3, 2, 2, 7, 5. And what is AR bar? AR bar will be x minus 1, y minus 2 and z minus 3. Determinant is 0. Let us solve this determinant properly. Get the equation of the plane. Please, you also do it yourself. I am prone to making mistakes here. I may make mistakes. Let me do it. Okay, let's solve this patiently. Solve this patiently, otherwise you make a mistake. Take all the steps. Mind you, that will be a quicker way, because otherwise we will make mistakes. Let me erase this. So that gives me let us take xyz now. 15x minus 14x is x minus 5y plus 4y minus y. 7z minus 6z is z. Minus 11 plus 15 is 4. 4 plus 6 is 10. I think again some mistake has been made. Can't find a mistake, but please see, the answer must be x minus y plus z is equal to 2. So here this must be minus 6. There must be a mistake here. Please see if you can spot it, but this is the way you solve the sum. Let me try to go back and see. minus 3, 2z minus 6 minus 5x plus, yeah, here it is, minus 5x plus 5. So I think I got a mistake here. I think you should be able to get the answer now. You understood the method, that is more important. So you can see here now the answer will be x minus y plus z minus 2. 6 plus 3, 9, minus 11 plus 9 is minus 2. So this is your final answer. Okay. The next question is, find a if the line lies in the plane this line entirely lies in the plane. So again we have to find a vector along the plane, and that will be able to give me the value of a. Now what are the things we have here? We have a normal, so we have to find a point on the plane, and if we substitute the point on the plane in this, we will be able to get the value of a. Now please note that as the line entirely lies in the plane, the point 3, 4, minus 3 also lies in the plane, because that is a point on the line. It is obvious, because as this line lies in the plane, every point on the line will lie on the plane. So in this, just put x equal to 3, y equal to 4 and z equal to minus 3, and we should get a. And that gives you a as 8. A very simple sum. Just the important funda is that if the line lies in the plane, then every point on the line also lies in the plane. So 3, 4, minus 3 lies on this plane. Just substitute and you will get a. Okay. The next sum is equation of plane containing two lines. This is one line, and also contains another line. Again, we are going to use the funda of coplanar vectors. Is the equation of plane which contains these two lines. Now, let us see this. If the plane contains these two lines, then the vectors along the line are also lying in the plane. So, I have one vector 4i plus 4j minus 5k. It lies on the line. And the second vector, that is this one, 7i plus j plus 3k, also lies on the plane. What about the normal then? The normal vector must be perpendicular to both these vectors. And if you want to find a vector perpendicular to the two given vectors, we have to use the cross product. So, the normal vector will be given by the cross product of these two vectors. 4, 4 minus 5. And that gives me the normal vector as 12 plus 5, 70 minus j 12 plus 35 47 plus 4 minus 28 minus 20. So this is the normal vector. 79 minus 47j minus 24k. Now if this is the normal vector, then what is the equation of plane? The equation of plane is given by ax plus by plus cz equal to d, where abc are the normal along the direction vectors of the normal. So the equation of plane will be now of the form 17x minus 47 5 minus 24z is equal to d. Now how to find d? You know, the 0.57 minus 3 lies on the plane, because as the line lies on the plane, this point also lies on the plane. Either this point or this point will give you the same answers. So let us put here x equal to 5, y equal to 7 and z equal to minus 3. That gives you the value of d. So 85 minus 47 into 7 and minus 24 minus 3. So let's find d here. $172. So the value of d is minus 172. So what is your final answer? The final answer is 17x minus 47y minus 172. This is the way you can find equation of plane containing two lines. There is another way of solving this sum. See which one you find easy. I will tell you the second method also. You can decide which method you want to use. See the situation. This is the plane. Let us take this point A as 5, 7, minus 3. R is any point x, y, z on the plane. And then I have got two more vectors. One is 4i plus 4j minus 5k. And the second vector is this. As these three vectors are coplanar, their triple product will be 0. So 4, 4, minus 5, 7, 1, 3. And what is AR? X minus 5, y minus 7, and z plus 3. This triple product will be 0. You can simply solve the determinant, you will get direct answer. So you can use either of the two methods. I would prefer to use this method because it is straightforward and it gives you answer in single determinant. You don't have to find a cross product and then substitute and all that. It is up to you. You can use either of the two methods to find the equation of plane containing two lines. You will get the same answer. Okay. Next one, find a ratio in which the plane divides line AB, where A is given and B is given 2, 3, 4. So this is the situation. This is point A, this is point B, and suppose this is a plane. The point on the plane, say P, and let us consider that P divides AB in the ratio k is to 1. So what are the coordinates of P? You can use the section formula, distance formula, section formula. K into 2 plus 1 into minus 3 upon m plus n, that is k plus 1. What is the y coordinate? my2 plus ny1. So k into 3 plus 1 into minus 2 upon k plus 1. And the third is k into 4 minus 1 into 1 upon. So this point P lies on the plane. As the point P lies on the plane, it satisfies the equation. So you can put x equal to this, y equal to this, and z equal to this, and x plus y plus z should give you 1. That's it. It is as simple as that, and you can get the value of k. So let us do that. Okay, can I remove this? Yeah, x plus y plus z equal to 1. So we have that gives me 9k minus 6 equal to k plus 1, and that gives me 8k equal to 7, and k is 7 upon 8. So what is the ratio? K is to 1, is 7 upon 8 is to 1. Which is same as 7 is to 8. So the required ratio in which P divides AB is 7 is to 8. So what we did here is we obtained the point P, and then we use the funda that P lies on the plane. We put it in the equation of the plane and we got the value of P. Okay, let us see one more sum. It has to find the equation of plane which passing through the point two minus 1 minus 3 and parallel to the two lines and in the same funda, this vector and this vector are parallel to the plane, so the cross product will be perpendicular to the normal. So we have got two vectors, 3i plus 2j minus 4k, with the second vector 2i minus 3j plus 2k. They lie in the plane. So the normal will be given by the cross product of these two vectors. So we will find the normal vector n bar I, j, k, 3, 2, minus 4, and 2 minus 3, 2. So that gives me n bar as 4 minus 12, it is minus 8. 6 plus 8, that is 14, and minus 9 minus 4 is minus 30. So since this is the normal, you can multiply by minus 1 here. So the equation of the plane will be 8x plus 14y. To find d, you can use either this point or you can use this point. Let us use this point. This point is 1 minus to 0. Let us substitute here to get the value of d. So it is 8 minus 28, and that gives you d as 2 8 minus 28, and z is 0. So 8 minus 28 will give you d as minus 20. Sorry, I made a mistake here. The point is 2 minus 1 minus 3 and not this. Extremely sorry. The point is this 2 minus 1 minus 3. So eight into 2. The lines are parallel, they are not lying in the plane. That is why these points don't lie on the plane. So you'll get 16 and that gives you d as minus 37. So the answer is 8x plus 14y minus 37. This is your final answer. Please note that these lines are parallel, they do not lie on the plane. So these points do not lie on the plane, they are given a point on the plane as 2 minus 1 minus 3. Okay, now let us do a sum on image of a point in a plane. You see this carefully. This is the plane. This is the point. Say P. Let this be the point M lying in the plane. And suppose the image is given by point Q, so that PM and MQ must be same. The point M lies on the plane, and obviously as you want to find the image, it is a normal to the plane. And we first have to find the coordinates of M. Before we find coordinates of M, let us find the equation of PQ. Please note that as PQ is perpendicular, it is parallel to the normal. And what is a normal vector? 2 minus 1 1. So a vector which is parallel to the given line is given by 2i minus j plus k. So in our normal regular method, the parallel vector is, and the point is 1 3 4. So what is the equation of PQ? X minus 1 upon 2 y minus 3 upon minus 1, so a minus 4 upon 1 equal to lambda. Now that gives me x, y, z as general point. We can take these points as coordinates of M. So what are the coordinates of M here? 2 lambda plus 1 minus lambda plus 3 and lambda plus 4. Right? Now, as this point M lies on the plane, we can put x equal to 2 lambda plus 1. We can put y equal to minus lambda plus 3. We can put z equal to lambda plus 4, and we can get the value of lambda. So let us do that. Let us substitute m in the equation of plane. So what do you get here is 2 times 2 lambda plus 1 minus plus 3. That gives you 4 lambda plus lambda. This is 5 lambda plus lambda. That is 6 lambda. And 2 minus 3, which is minus 1. Minus 1 plus 4 is 3 plus 3. That is 6. And that gives you lambda as minus 1. Right? So now we can find the coordinates of point M. By putting lambda equal to minus 1, we can get these coordinates. So what are the coordinates of M? Put lambda equal to minus 1. So minus 2 plus 1. Lambda equal to minus 1 will be 1 plus 3. Minus 1 plus 4 is 3. So these are the coordinates of M. And once you get the coordinates of M, you can easily obtain the coordinates of Q. This is the situation. This is 1, 3, 4. This is minus 1, 4, 3. And let us take coordinates of Q as x, y, z, which is the image, and this is the midpoint. So minus 1 will be 1 plus x upon 2, and that gives you x as minus 3. Then 4 will be 3 plus y upon 2, that gives you y as 5. And lastly is 3. And that gives you z as 2. So the image is minus 3, 5, 2. This is the image of the point in the plane. So I think many sums we have solved here. Now we will be doing some complicated sums, some little bit complicated sums in the next part. Let us not do it in this part. Let us call it off here, and some complicated sums we will be doing in the last part.